Hey guys, welcome back to math class. Well, sort of. Okay, welcome back. Hopefully you guys took advantage of a little bit of a break. Today we're going to continue our discussion on the chapter on probability. All right, we're going to move into section 3, talking about the difference between independent and dependent events. All right, so first thing we want to do is we want to figure out what determines whether or not an event is independent or dependent. Well, the question that you have to ask yourself when determining that is, does the previous event affect the probability of any future events? Okay. If that previous event affects the probability of something happening after that, then that means that the second or third or fourth or so on event is depending on what happened before that. If it's independent, then that means that it has the same probability no matter how many times you do it. Doesn't matter what the result was in any previous events. All right, so let's take a look at the most simple example for an independent event, and that is a coin flip. All right, so hopefully we all know there's two sides to a coin, a heads and a tails. All right, so if we flip a coin, then we have an equally likely chance of it coming up one or the other. So we've got a 50% chance of either getting heads or tails, or a probability of 1/2 for each. So the probability of that coin landing on heads is 1/2, and the probability of it landing on tails is also 1/2. All right, so let's say I flip that coin, all right, and then I'd go to flip it again. If I flip it a second time, does it matter whether or not I got heads or tails on the first flip? Does that change what the probability is of it landing heads or tails again on the second flip? Well, the answer to that is no, because I'm doing the exact same flip with the exact same coin. The coin doesn't know what it landed on the previous flip, so it's not going to affect what happens next. It's still a 1/2 chance for each heads or tails. All right, so on the first flip, let's say I get heads, okay? On the second flip, all right, only two things can happen, right? I can get heads or I can get tails. Okay, same two things that can happen. So that's my second flip there. What's the probability of it landing on heads? Well, it's still 1/2 because this is an independent event. And the probability of it landing on tails is still 1/2 because I'm still flipping the same coin and it's still a 50-50 shot. Okay, now let's say I flip it a third time, all right? Let's say that it landed on heads the first time and it landed on heads the second time. Well, if that was the case, then what can happen on the third flip? Well, you guessed it, the same exact thing that happened on the first two. It can either be heads or tails. Okay, so what's the probability of it landing on heads? Well, it's still 1/2. And what's the probability of it landing on tails? 1/2. Okay. Now let's say that on the first one it lands heads, and on the second flip it landed tails. All right, is that going to affect the next flip any different? No, it's not. When I flip that again, I've still got two options, either heads or tails. Okay, both still have a 1/2 probability of coming up. All right, so if I go with the first flip, all right, comes up heads. All right, it can, and then the second flip's either going to come up heads or tails. And then the third flip, same thing. So independent events, as you can see, the probability of all these is the same for each flip. Okay, and so we can do the same thing with our tails. If it comes up tails first, okay, again, we've got two options, heads or tails. Oops, wrong color. And we can continue to do that as well. I'll bring it down here so it's all together. All right, it's a little scrunched up, but you get the idea, okay? All right, so these again all still have a 1/2 probability of happening each time, because again, we're flipping the same coin and it's an independent event, so the previous flips have no effect on the probability of it coming up heads or tails, okay? So at any given point, it could come up either one, all right? The next question is, how do we determine the possible total number of events that can happen if we flip that coin 3 times? All right, well, that's why we do this tree here. We start off with one flip. It can be either heads or tails. If it's heads, the next one can either be heads or tails. If the second one's heads, it can either be heads or tails. And we do that for each flip. And so if we follow the branch from the top all the way down to the end of each branch, that will give us all the possible combinations of things that can happen if I flip that coin 3 times in a row. All right, and then all I have to do is I count how many total branches there are at the bottom of the tree, and that will tell me how many total possible outcomes there are. All right, so it can be heads, heads, and heads, 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 tails, heads, tails, heads, heads, tails, 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 heads, heads, tails, tails, heads, tails, heads, tails, or tails, tails, tails. So those are 8 different things. So 8 possibilities is what you're going to end up with for results if you flip this coin 3 times. Okay, so how do I determine the probability of any one of those happening? Well, what I'm going to do with independent events is I am going to simply multiply the individual probabilities together to tell me what's the probability of that particular pattern happening. So let's say I want to find the probability, if I flip a coin 3 times, of it coming up heads all 3 times. So I'm going to take the individual probabilities. So 1/2 is the probability of it coming up heads on the first try. The next flip, I still have a 1/2 probability of it coming up on the second flip. And then I also have a 1/2 probability of it coming up heads on the third flip. So I'm going to simply multiply the 3 individual probabilities together, and that will give me the probability of it coming up heads all 3 times, is 1 out of 8. And obviously you can see, since there's 8 total possibilities, it can only happen one way for all heads to come up on each flip. So that's 1 favorable outcome out of a total of 8 possible outcomes. All right, now let's take a look at some examples of dependent events. All right, here we have our number cube. All right, so remember the number cube is 6-sided. All right, it's got numbers 1 through 6 on each side. And if we roll this number cube, then we know that it's equally likely chance of it coming up any of those 6 numbers, right? So the probability of any one of these numbers coming up should be 1 out of 6, okay? So let's take a look at some examples. If I roll this 3 times, all right, each roll is going to be independent of the other. So the second roll is not going to depend on what I rolled on the first one. The cube doesn't remember what I rolled the first time or the time before that when I roll it again. So every single time I roll it, just like the coin flip, the probability is going to be the same. All right, so these are, again, are dependent events. All right, so we know that the probability of, let's say, rolling an even number. All right, there's 3 even numbers. There's 6 total sides. So we've got a 3 out of 6 or 1/2 probability of rolling an even. All right, so that's on the first one. If I roll it a second roll, and we'll say, what's the probability of getting a number less than 5? So a number that's less than 5. Well, there's 4 of those, 1, 2, 3, and 4. So 4 out of 6 or 2/3. All right, so those are the 2 independent probabilities of those separate events, okay? Since they're independent of each other, one doesn't affect the other whether I roll it first or second. Now, if I say, what's the probability of rolling an even number, then a number less than 5, I'm going to take the two individual probabilities and simply just multiply those two together. So 1/2 is the even times 2/3, which is probability of rolling less than 5. All right, multiply those together straight across. So I end up with 2 out of 6, or a 1/3 chance of rolling an even number than a number less than 5.